think about what is a polynomial. Okay, let's think about the definition for polynomial first. A polynomial is an algebraic expression often written with px. Well, you know we have fx, gx, hx. For polynomial, we give a name as px. Well, it's not necessary to give px, but we normally express it in the px. Okay, what is polynomial? Very important definition. Non-negative, first requirement. Whole number, second requirement. Power, that's the third. Okay, three requirements. Non-negative integer powers. Okay, so let's have a look at the first one. This is not a polynomial, because if you can write that into x to the power of -1, that's a negative integer. Okay, it's failed the first one, non-negative. It can be 0, can be x to the power of 0, which is 1, but it can be a constant like 2, which is 2x to the power of 0, but it can't be negative. So the first one failed because that's x to the power of -1. Second one, if you can look at this one, x squared minus 1 square root of that. That's x squared minus 1 to the power of half. I need integer. Fractions, not good. Not polynomial. Okay, not a polynomial. Fail the second one, integer. Okay, whole number. This can't be a polynomial. Well, the third one, we can see all integers and whole numbers and positive numbers, but this is not a polynomial. This is an exponential, because I need a constant power. Constant power. This is a power contain variables, which is not good. So this is called exponential. Well, if you have learned exponential last year, you know exponential is the power contain variables. That's exponential. But I need polynomials, which is x as the base and that as a number as the power. So this is called polynomial. 2 to the power of x is called exponential. Okay, you need to know what is polynomial. So x to the power of 2 is polynomial. 2 to the power of x is exponential. So x can't be the power. X must be the base. And then your power must be a constant. Must be a constant. So all of these are not polynomials. Okay, all of these are not polynomials. Well, in general, we have an expression. What's the bell for? Okay. In general, we express px in the form of this. Okay, we can see what's that. All of this a, they are coefficient. Well, they are the coefficient of the x term. And then we have x to the power of n, x to the power of n minus 1, x to the power of n minus 2, until x to the power of 2, x to the power of 1. And here we have x to the power of 0, which is a 1. So the last one is a constant term, but you can see as x to the power of 0. So I write things in a decreasing order. All of the a values are called the coefficient. And then we have a special polynomial, which is called 0 polynomial. That's just px equals to 0. Well, that is called a 0 polynomial. We don't really need that, but this is just a special name for it. Px equals to 0, that's called the 0 polynomial. So what is a leading term? That is important. Leading term is the term of the highest index among those terms with a non-zero coefficient. So, well, you just look which x contain a highest power. That is the leading term. Well, including the coefficient. Including the coefficient. Well, if you can see this one, the leading term is 3x to the power of 2. That's x to the power of 2 is the highest term. Then 3x to the power of 2 will be the leading term. That's called the leading term. Okay, what is a monic polynomial? Monic polynomial is the leading term got coefficient of 1. Monic polynomial is the leading term has a coefficient of 1. So x to the power of 4 plus x to the power of 2 plus x minus 1. That's a, well, I can say 2, I can put 3 here, but this is a monic polynomial because the leading term has a coefficient of 1. Okay, leading term has a coefficient of 1. Okay, constant term basically is the constant in the end, which got an index of 0 because it's x to the power of 0. The term not involving x is the constant term. Well, that's the constant. There's some definitions for polynomials, and let's have a look of binomial. Okay, what is a binomial? And what is a trinomial? Polynomial with 2 terms are called binomial and 3 terms are called trinomial. So how many things you have? So for example, this one. This is a quadratic because the highest power is 2. Okay, that's a quadratic. But it with 3 terms, so it's called a quadratic trinomial. Okay, this is called a quadratic trinomial. Trinomial is talk about how many terms, and the quadratic is talk about what is the highest term. Okay, what is the highest power? The highest power is 2, so that's why it's called a quadratic. How many terms do you have? 3 terms, so it's a trinomial. So that's a quadratic trinomial. This is a quadratic binomial because power of 2 is still the highest term. That's a quadratic. How many terms do you have? You have 2 terms. That's called a binomial. So that's a quadratic binomial. Well, you can have a look. For example, we have x to the power of 4 plus 2x. This can be a, okay, I can say that's a monic because the leading term is 1. Monic quartic binomial. Well, why monic? Because the leading term got coefficient of 1. The leading term got a power of 4, so that's a quartic. Okay, power of 4 is a quartic. The highest term is 4, it's called a quartic. 2 terms, binomial. Okay, 2 terms, binomial. So that's a monic quartic binomial. That's how to name a polynomial. Okay, that's how to name a polynomial. Okay, the next one says, well, the terms of polynomial are best placed in order from the largest to smallest power of x. Well, that's a good manner to write things. Also, it's easier for you to see all the terms and easy for your calculation as well. So keep this habit to put polynomial in the highest power to the lowest power to place those terms. Okay, let's have a look at all of those polynomials in this table here. So how to name the polynomial, it depends on what's the leading term. Look at the leading term's power, that's how to name it. Well, for a constant, it's just called a constant. You know power of 1 is a linear, power of 2 is a quadratic, power of 3 is called a cubic, power of 4 is called a quartic. That's with special names for the first 4. But from power 5, we call that polynomial of degree 5. Well, if a 6, we say polynomial of degree 6. If it's a power of 7, we say polynomial of a degree of 7. So we don't give special names anymore. It's easy, just talk about polynomial of degree 5. Okay, degree. What's the degree of the polynomial? The degree is the highest power. So degree of 0, degree of 1, degree of 2, degree of 3, degree of 4, and degree of 5. Okay, constant is degree of 0, linear degree of 1, quadratic degree of 2, cubic degree of 3, quartic degree of 4, and polynomial of 5, degree of 5. Well, coefficient of x. Well, for the first one, coefficient of x is just a 0. There's no x term. Coefficient of 0. For the linear, coefficient is negative 0.1. For the next one, the coefficient of x is negative a. The cubic coefficient is 0 because no x term. Coefficient of 1 for the next one. And coefficient of negative 3 for the polynomial of degree 5. Last one, let's talk about what's the constant. The constant is negative 2.3. Constant is 1. Constant 0. Constant negative 3 over 2. Constant of 0 and constant of 0. Okay, let's have a look at example 1. Example 1, first one says evaluate P0. Okay, evaluate P0. So P0 is just A. P0 is A because when you get x0, 0, 0, you just have A left. So P0 is A. Second one, what's P1? P1 is 1 minus 1 minus 2 plus A. When you sub x equals 1, you only change x. You don't change A. Okay, A is the constant. It's just something you don't know what the value is. But when you replace x by 1, you only change the x value. So what you have here is A minus 2 for P1. P1 is A minus 2. Number 2 says P2 equals to 3. Well, let's have a look what's P2 first. P2 equals to 2 to the power 4, which is 16, minus 8, 2 to the power 3, and minus, well, 2 times 2 squared, which is 4, and you minus 8 again, and plus A. So P2 is just equals to A. And P2 equals to 3 as well, because that's given. So A equals to 3. This is nothing new. It's just give you a coordinates to find variables, okay, to find a constant A. Just do substitution and then solve for that. All right, example 2. Example 2. Example 2 is negative 4 to 3, mapping to R, fx equals to that, and gx is negative 2 to 5, mapping to R, gx equals to that. Okay, question is asking you to find fx, gx, fx plus gx, gx minus fx, and fx times gx. You know how to add the rules, but the question I want to ask is, what is the domain for all of these functions? That's what I want you to think. What's the domain for those functions? What we need to do? Domain for f is negative 4 to 3. Domain to g is negative 2 inclusive to 5 exclusive. What's the domain if you add to function? What is it? Well, you can just tell me what to do, or you can tell me the answer. Domain? Domain? Anyone? What's the domain? Think. You want to add two things. You need to make sure you have a graph, right? At that point, you have both graphs at this point.
Would it be negative 4 round bracket to 5 round brackets. Just take the minimum and maximum.
The minimum and maximum?
I'm not sure.
Let's have a think. Well, like before answer this, give me the answer directly. I want to ask, at x equals to -3, at x equals to -3, do we have graph for fx? Do we have some graph for fx? At x equals to -3, do we have graph for gx? Can I add them then? At x equals to -3. So what I need to find now? The intersection, that's right. You need to make sure for those x, you have both graphs. Then we can add, we can subtract, we can times them. Otherwise, we can't do any. We only have, for example, graph is here and some graph is here. Well, for this part, I can't times it. I have no graph for this part. So I have some graph here, some graph here. For this part, I can't add them because there's no graph to add. So what I need to find, the domain, is the intersection. So to find intersection, well, I have -4, -2, 0, 2, 4, have 3, and I have 5. So for the first one, I have -4, 2, 3. Inclusive is like this. For the next one, I have -2, 2, 5. Exclusive. So the part I have graph is from here to here. I have domain for both graphs. So x needs to be in between -2, 2, 3 inclusive, because I have graph at -2 for both graph. I have graph at -3 for both graph. So what is more important compared to the rule? It is the domain. Okay, it is the domain. We need to have graph at that place, have both graphs at one point, then we can add them. Otherwise, we can't add or subtract all times. Well, to find the rule, basically, it's very easy. fx plus gx, you use that to add that. Well, if you go gx minus fx, well, I just go for 1. At gx minus fx, what I will have is 3x cubed plus a third x plus 3 minus a bracket 2x squared plus 3x minus 1. Well, what do I have is 3x cubed minus 2x squared. Okay, that one. For the x term, well, a third will minus 2/3. So you have a minus a third x. And then 3 minus -1 will be plus 4. That's the rule for gx minus fx. Well, if you want to talk about the function notation, you say g minus f dot dot x belongs to -2 to 3 mapping to r, comma gx minus fx. Or you can say g minus f bracket x. I can write in that way as well. That equals to 3x cubed minus 2x squared minus a third x plus 4. Okay, so the plus and times will work in the same way. I'm not going to show that, just too long to write. It's not hard, but the domain, okay, important thing is the domain. When you do things for two functions, you need to find the intersection domain for both graphs. Okay, intersection, well, if you want to add 3 functions, you need to find the intersection for 3 graphs as well. Well, I'll skip the box there, which is not really important. It's too complex to explain. You don't really need that. Have a look at example 3. Have a look at example 3. Okay. If you have two polynomials, if you want two polynomials to be the same, you want them to be equalized each other, you need to get the coefficient of the same power term to be the same. So if you have x to the power 4, x to the power 4, you need the coefficient of x to the power 4 to be the same. So let's have a look at the example 3 here. I have 9x to the power 3, and then I have x to the power 2, and I have power of x, and I have a constant. This is the constant. Okay, this is the constant, all of that. To equals to cx to the power 3. 0x squared, 0x, and 0 constant. Which means if you want left hand side to be the same as right hand side, your c value must be 9. Okay, the x to the power 3 and x to the power 3 must be the same. Okay, x to the power 3, x to the power 3 must be the same. Then a minus 5 must be 0 because there's no x squared term on the right hand side. It's 0x squared. Okay, I don't have any x squared. So a will be 5. I can't have any x term. So 2b minus a equals to 0. B equals to a half a. B will be 5 over 2. Okay, because I don't want 0, I don't want any coefficient of x. So 0 coefficient, 5 over 2 times 2 minus 5 will be 0. So that needs to be 0. And number 4 is the check. Because I have b value, I have c value, I need to check for that. Well, if it can't be 0, which means these two polynomials can never be the same. Okay, it can't be the same. It's a wrong statement here. So I need to check. So negative 13 over 2 minus 5 over 2 and plus 9. Let's see what that equals to. That equals to negative 18 over 2 plus 9. And that equals to 0, which is a good check. Because I have 0 constant, I have 0 constant at right hand side as well. So I can't have any value here. If you solve out that equals to 1 or 2, which means those two polynomials will not be the same. Okay, will not be the same. Okay, that's example 3 here. Well, for the formula here, I don't need you to remember this one, like the middle one, the power 4. But all of the rest, you need to memorize that, especially the last one. Well, you know how to factorize difference of perfect square, a squared minus b squared, that's a plus b times a minus b. But you also need to be able to factorize a cubed plus b cubed and a cubed minus b cubed. So a cubed plus b cubed is a plus b. A squared minus ab plus b squared. And a cubed minus b cubed is a minus b, a squared plus ab plus b cubed. What we will do for this chapter, okay, just give you a general view on what we will learn in polynomials. We will learn how to factorize. And then we'll learn how to solve functions. And we'll learn how to sketch polynomials. And they all, like, to sketch and to solve, they need to factorize the polynomial first. So if you can factorize, basically we have done everything. Okay, we have done everything. So to factorize the cubic, that's very important, okay? A cubed plus b cubed and a cubed minus b cubed. How to factorize those two is by using this formula here. And also a squared minus b squared, that's what we learned last year already, difference of perfect square. And then the top two lines are expanding. Well, expand perfect square, a plus b squared, a minus b squared. We know that. And a little bit extension is a plus b cubed. Okay, a plus b cubed, a and a minus b cubed. So we need to know how to do that as well. All right, so let's quickly expand this. Okay, let's quickly expand this. So 5 minus c over 3, that's 25 minus 10 over 3c plus c squared over 9. Okay, a squared minus 2ab plus b squared. Okay, plus b squared. Square is easy. Let's have a look at the cubic. Okay, for the cubic, what I will have is a cubed minus, okay, a minus b cubed. If you can look at the formula, it's minus 3a squared b and plus 3a b squared and minus b cubed. Okay, that's the formula. A cubed minus 3a squared b plus 3ab squared and minus b cubed. Okay, you should be able to complete that by looking at the formula above, but like you need to remember that. Okay, you need to memorize that. That gives me 8x cubed okay, a is 2x, b is 1 over x, a minus b cubed. And then we have x squared and 1 over x become 1x, so 12x. Okay, that's 4x squared times 3, so 12x squared, and then divide by x, so 12x. Plus, that's 6x over x squared, so 6 over x. 6 over x. And minus 1 over x cubed. Okay, that's how we expand that. Next one is plus a plus b cubed. So a is x, b is 1 over x squared. That will be x cubed, a cubed plus 3a squared b plus 3ab squared plus b cubed. That's x cubed plus 3 plus plus that's x to the power 4, 3 over x to the power 3 plus 1 over x to the power 6. Okay, last one. What's the easiest way to expand this one? What's this one? So what is A, what is B? Yep, so we can say that's 5 minus 2b and that's 5 plus 2b. So that's a minus b times a plus b. And the easiest way to expand it is 5 squared minus 2b squared. Okay, instead of like expanding one by one. So 25 minus 4b squared. Okay, this is some expansion questions. Let's go to the next page. Okay. Have you learned long division last year? Like polynomial long division? Yeah, we have done that. Okay, so just quickly revise on long divisions. So number long division. 297 divided by 9. Okay, if you can just quickly do that. 297 divided by 9. Well, 29 divided by 9, I have a 3. And then the 3 go to times the 9, we have a 27. And we subtract between that, we have a 27. And then the 27 divided by 9, we have a 3. 3 times the 9, we have a 27, and that gives me a 0. So I can write my result in two ways. Okay, the first way I can write it, this equals to 33. Or I can write as 297 equals to 33 times by 9. There's no remainder, that's fine. We'll talk about the remainder one later. So that's the two way I can write this. Okay, let's have a look at the next one. Two, 1, 7, 8. Divide by 7. Have 3. 21. Well, that's a 0, so I will make the 7 down here. 7 divided by 7, that's a 1. So we have a 0 again, and then the 8 will come down. 8 divided by 7, we have a 1, 7, and the 1 is the remainder. Okay, two ways again I can write the solution. So I can write this equals to 311 plus 1 over 7. Have a think about that. We have 311 sevens in 2178. And then we remain as 1. So the 1 divided by 7 will be 1 over 7. I can say that's 2177 divided by plus 1 and then divide by 7. So I will have 2177 divided by 7 plus 1 divided by 7. So that is 311 plus 1 over 7. So that's how we get this result as well. But also I can write in another way, which is 311 times 7 plus 1 equals to 2178. Okay, there are 311 sevens, so you times them and then plus the remainder, that should give you 2178. That's after you do long division, how you can express your answer in the right way. Okay, the next one, 4 or 5 divided by 7. Okay, 4 or 5 divided by 7. So 5 times 7, 35, 55. Well, 7 times 8 is 56, it's too much. So it's 7 times 7. And subtract, we have a remainder of 6. Okay, I have a remainder of 6. So the result I can write here is 57 plus 6 over 7. Or I can write as 57 times 7 plus 6 equals to 4 or 5. Okay, this is number long division. So what we can do is polynomial long division as well. So just go through that. Well, let you know, I'm not going to use long division a lot and in the polynomial chapter. I'll go through another method with you. But like, those methods can only work for something trying to divide by a linear. Okay, trying to divide by linear. When you're trying to divide by a quadratic or like cubic, it's not working better for that method. So we need to go through long division for those questions. Okay, so just be careful. First of all, you need to write things in a decreasing order, like cubic, quadratic, linear, and constant. And you can see we have 2 terms only for the quadratic. We need a 0x to be there to keep the position for the x term. So what I'll do is 3x cubed minus 2x squared plus 3x minus 4. This will divide by x squared plus 0x minus 1. I will write the x term out as well. It should be 3 terms for quadratic. So even though the coefficient is 0, I can still put the 0 there to keep the spot. Alright, so how do we do long divisions for polynomials? We have the first term go to divide by the first term, which got a 3. Okay, I got the 3x. So same as the number thing, you write something on top, you times with what you're trying to divide. So you will have 3x cubed. Okay, this is 0x squared. You don't have x squared term because 3 times 0 is 0. So 0x squared minus 3x. And now you will subtract between that. So 3x cubed and 3x cubed definitely is 0. Minus 2x squared minus 0x squared, that's a minus 2x squared. Minus 2x squared minus 0x squared become a minus 2x squared. Plus 3x and subtract negative 3x. What's that? What's 6x, that's right. It's a positive 3x minus a negative 3x that will give you 6x. And then you have the minus 4. You get the next number down, which is the minus 4. And then same as before, you use the first number divided by the first number. What you have is a negative 2. Negative 2x squared divided by x squared, you have negative 2. Now the negative 2 will times by x squared minus 1. So you have negative 2x squared minus, well, you can say plus 0x again, because minus 2 times 0 is 0. So plus 0x and then plus 2. Six x minus 0x, we have 6x. Minus 4, subtract 2, you will have minus 6. That's the remainder. Okay, we have nothing to check from the top, and we can't divide again because it's a linear, can't divide by a quadratic. So I can express my answer in two ways. So the first one is when they divide by each other, you have 3x minus 2 plus 6x minus 6 divided by x squared minus 1. Okay, so whatever on top and then the remainder over the dividend. So this equals to 3x minus 2 plus 6x minus 1 over x plus 1 and x minus 1. So that gives you this. I can simplify that. Or I can have px equals to 3x minus 2 times x squared minus 1 and plus 6x minus 6. So that's this number times this number and add by that number. Okay, so two ways to express. Give a general expression. So the general expression will be when you have a px. You're trying to divide by another polynomial. You have the quotient, like whatever that equals to, and then the remainder x. So the px will equals to qx times dx and plus the rx. And that's the general expression. Or you can say px divided by the dx, you have the qx plus the rx over the dx. They are the same thing. Just show you one more example here. A quatic divided by a quadratic. Two x to the power 4. Well, power 4, and then we have power 3. We don't have power of 2. Can you see that? We don't have power of 2. We'll add 0x to the power of 2 here. And then 13x. And then plus 10. We need to keep the spot when we do long division because it's easier. Well, it's not really necessary and you must do that. It's because it's easier for the calculation. So I have 2x squared minus x and then plus 4. Well, first term and first term, 2x cubed, 2x power 4 divided by 2x squared, we have x squared. So 2x to the power 4 minus x to the power 3 plus 4x squared. What's the difference will be here? What's the difference? What's the second column? How many x cubed? 2x cubed. And how many x squared? Minus 4x squared. That's right. And then get the 13x down. Well, 2x cubed divided by 2x squared, we have a plus x. Then we have 2x cubed minus x squared and plus 4x. Alright, how many x squared I will have? How many x squared? Minus 3x squared. How many x? 9x. And then plus the 10. And then minus 3x squared divided by 2x squared, that gives me a minus 3 over 2. A minus 3 over 2. So we have minus 3x squared plus 3 over 2x and then we have a minus, what's that, 6. So what's the constant? What's the remainder constant? 16? How many x? 15 over 2x. Okay, that's the remainder. We can't divide anymore because it's linear already. So I can have 2x to the power 4, that x plus 13x plus 10 divided by 2x squared minus x plus 4 equals to x squared plus x minus 3 over 2 plus 15 over 2x plus 16 divided by 2x squared minus x plus 4. So simplify that. Well, it's not going to change the quotient part. That's just stay like that. And our times 2 on top and bottom. That's 15x plus 32 divided by 4x squared minus 2x plus 8. Times 2 on both top and bottom for every single term. Or we can write as px equals to x squared plus x minus 3 over 2 times 2x squared minus x plus 4. And then add by the remainder, not the simplified version, the remainder. The remainder is 15 over 2x plus 16. You need to add that, not the 15x plus 32. You can't add the thing you have simplified. one, I want you to use the rest of the time to do question on page 59. Divide the polynomials and then evaluate the p negative a half and p negative 2 for each of that. Okay, just try to do that now. Yeah. Yes. Divide as well. Times divide.